Okay, we're going to try something a little bit different this time. This is the 5th or 6th plus time I have attempted to record this video, so I have actually run out of empty booklets to write on at the moment. This is going to be our booklet on solving systems of equations by substitution. We have 3 different options when you're solving systems, whether you're solving it graphically or algebraically, it doesn't matter. You may always end up with one solution, which are 2 lines that do intersect at a single point. And they also share that single point on either of their equations separately, but then when you graph them together, they intersect at exactly one point, meaning there's one solution to the system. There's also a no solution option, which happens when you have 2 lines in the same system, but they never cross or they never intersect. So here we're going to be talking about our parallel lines with the same slope. And then the third option is a mini, or you could even call it an infinite solutions equations or system of equations. That is always going to be when you have 2 equations. So for linear equations, it's always going to be when you have 2 equations that are the same equation but potentially written in different forms. So for example, standard form or slope-intercept form, you may not be able to immediately tell that they're the same equation, but they are. So this is where it gets just a tiny bit different. I have already done the first page here. Because I did it on the last video that didn't record properly. So we're going to open it up, but I'm going to explain it here step by step, okay? So on example 1, we have the 2 equations, 2x plus y is equal to -1, and x is equal to 2y minus 13. When we're talking about using the substitution method for solving systems, we are quite literally saying that x is equal to 2y minus 13, meaning they're the exact same thing. Wherever you see x, you can call it 2y minus 13. They're interchangeable. They are equivalents. So since x is 2y minus 13, I can actually come down here and take that top equation, 2x plus y is equal to -1, and instead of doing 2 times x here, I can do 2 times what x is equal, and just plug in that 2y minus 13, rewriting the remainder of the equation. So plus y is equal to -1. You got to finish writing that whole equation out. Then your next step is going to be to distribute. You've got the 2 on the outsides of the parentheses. 2 times 2y is 4y. 2 times -13 would be -26. So you end up with 4y minus 26 plus y is all equal to -1. Your next step would be to check, do I have like terms on either side? Well, we know on the right I don't because we only have one term. We've got one single integer. But on the left-hand side, I actually do have 2 different sets of y's. I have a 4y here and a positive 1y there, so you need to combine your like terms. 4y plus y is equal to 5y. And then you're just going to rewrite the rest of the sentence there. That -26 or minus 26 does not have any other integers on the left, so that all becomes 5y minus 26 is equal to -1. Your next step is to try to isolate the variable. Y has to remain alone on one side of the equation, but you can see here we have integers on both sides of the equation. Since that 26 is negative, to move it over to the other side and away from the variable, you need to do the inverse operation. -26 plus 26 would cancel out and equal 0. -1 plus 26 over here would equal 25. So we're left with 5y is equal to 25. Now to isolate the variable from its coefficient, you do the inverse operation again. 5y is an expression that says 5 times y. So we're going to do the inverse and divide. 5 divided by 5 is 1y. 25 divided by 5 is just 5. So we end up with y is equal to 5, and we're halfway there. The solution to any system has to be a point, a coordinate point, which we always know contains both an x and a y. We have found our we found our y. Now it's time to go ahead and find our x. Because y is equal to 5, we can plug it into either equation to solve for x. We know y is equal to 5. When you're looking at your 2 equations, you have the option to choose whichever equation you want to plug it into. I personally chose x is equal to 2y minus 13 because I already saw that x was alone here on the left. I knew I was not going to have to do anything extra because I'm solving for x in the first place. So I come over here and I rewrite x is equal to 2y minus 13. We just said down here that y was equal to 5. So I should be able to plug 5 in substitute, there's that word again, substitute 5 anywhere there's a y. So then x in effect is 2 times 5 minus 13. 2 times 5 is obviously 10. So you get x is equal to 10 minus 13, or x is equal to negative 3. The solution to this system is the point negative 3, 5. That is where the two lines intersect. I'm going to go ahead and cut the video off here at example number 1 and put examples 2 and 3 on a separate video just to avoid any technical issues. But if you need to pause the video here to collect any information you did not write down yet, please go ahead and do so.